This lecture is the third of 5 lectures on early season apple diseases. In the second lecture, we focused on apple scab caused by Venturaria inequalis, including common symptoms and the disease cycle. In this lecture, we will focus on apple scab disease management. The learning outcome for this lecture is to identify management strategies that are used to control primary and secondary apple scab. An emphasis will be put on reducing primary scab inoculum in the orchard and preventing primary scab infections. Managing primary scab infections requires tactics that minimize ascospore discharge and spread. Next to planting varieties with resistance to apple scab, integrating fungicides and best cultural and sanitation practices are the most effective strategies. If you remember from the introductory lecture, apple scab is the driver of an early season apple disease fungicide program. Fungicides to control primary scab are applied beginning at green tip and applications end at petal drop. Fungicides are typically applied on a 7 to 10 day schedule, which is referred to as a calendar spray program. However, fungicides can also be applied using an infection prediction model to improve the efficiency of fungicide applications. There are many effective, protective, and eradicative fungicides registered for apple scab control, although the number of fungicides with different modes of action is limited. The most well-known primary apple scab infection model is the revised Mills model, which predicts the timing of ascospore maturity and release of ascospores. The Mills model was first published in 1944 and modified in 1980 by Jones et al. The model utilizes temperature and measurable precipitation to predict ascospore release time, as well as the percent of spores released. Measurable precipitation is defined as 1/10 of an inch of rain or dew. The output of the model is used to guide the application of fungicides, specifically the timing of the fungicide applications. Ascospores mature as spring progresses, with a few ascospores usually maturing by bud break or green tip. The proportion of ascospores maturing progresses slowly until about the tight cluster stage of blossom development. From tight cluster through bloom, the percentage of mature ascospores rapidly increases, with most ascospores matured by the end of bloom. This graph shows ascospore maturity, and the next slide will show the weather summary for Worcester in 2019. So on March 25th, green tip occurred in Worcester, and that is shown by the green dotted line, and I'm also showing the image here. So the way that the ascospores are released is they're released from this green tip stage all the way to the end where you have petal drop. During tight cluster, this is when the majority of ascospores are released, and so you have an increase over a relatively short period of time of the number of ascospores that are matured and released. So in 2019, by around April 24th, if we look at the end of this red line here, you can see that about 80% of the spores were predicted to have been released. This is the corresponding temperature and measurable rain data to the spore maturation figure that I just showed. The blue bars here represent the daily low and high temperatures in degrees Fahrenheit, and the green bars represent the total rainfall in inches. The red bars are the predicted temperatures and the yellow bars are the predicted rainfall. So at this time, all of the data up until around April 22nd were real time, and then following April 22nd, it was showing predictions for rain as well as temperatures. If we overlay the two graphs, you can roughly see how ascospore maturity progresses relative to temperature and rain. We can also do a rough prediction as to when the mature ascospore is released, since we know the release occurs when temperatures reach around 50 degrees, which is right in here, and there is a measurable rain event. So using these two parameters, we can predict that there would be approximately 3 ascospore release times in this predicted area between April 22nd and April 24th. The only problem with using this method to predict ascospore maturity and release is that at this point it's not considering the wetting period. So the revised Mills model table includes the number of hours of wetting to produce primary scab infections. The table also provides the approximate number of days required for lesions to appear after an infection is initiated without needing further wetting periods. For example, if we look at the 59 to 57 temperature range, at a measurable amount of rain, at least 7 hours of wetting period is needed to initiate an infection. And that corresponds to approximately a 12 to 13 day incubation period before symptoms are first observed. Additional days may be required if conditions during that 12 to 13 days are unfavorable for lesion development, such as prolonged periods of temperatures above 80 degrees. The revised Mills model is available on the Network for Environmental and Weather Applications, or NUA, and this application of this tool is free to Ohio producers. We currently have 36 weather stations in Ohio that are linked to NUA. For the output that I'm going to show here, I selected Worcester for the weather station, and I entered the date of interest as April 19th, 2019. The tool also allows you to enter the green tip date for the variety that you have planted in your orchard, or you can default and use the 50% green tip date for Macintosh apples. The output provides data for 2 days prior to the date of interest. So our date of interest was April 19th. So you can see that it provides data for 2 days before your date of interest, and it predicts 5 days after your date of interest. The top graph, or the top table, shows the maturation summary, which was also depicted in the graph that I showed in the previous slide. On the bottom slide, you see infection events summary, and infection events are color-coded as red. The word combined means the wetting event on this day is combined with another wetting event, using the rule that for 2 successive wetting periods, the first started by rain should be considered a single uninterrupted wetting period if the intervening dry period is less than 24 hours. So in this case, we had a combined event on April 19th. However, on April 20th, it was a single event, suggesting that the following wetting period would be less than 24 hours. So using the revised Mills table, we can look up when we would expect to see symptoms from these infection events. So the bottom slide shows you your average the bottom table is showing average temperature, leaf wetness, and hours of relative humidity, as well as rain amount. And the model considers your temperature, your leaf wetness hours, and measurable rain. Remember, that needs to be greater than 1/10 of an inch. So the temperature here on these predicted infection events, the temperature ranges between 44 and 48 degrees Fahrenheit, and the wetting period is between 14 and 20 hours, and we did have a measurable wetting event. So we can go to the Mills table then and look at when we might expect to first see symptoms. So at 48 degrees temperature, 12 wetting hours, we would expect that infections would be first observed within 17 days of the ascospores initiating infection. So what this means is that the grower should apply a preventative spray prior to the infection and an eradicative fungicide within 17 days to prevent the formation and spread of secondary inoculum. So using best sanitation practices in the orchard is a critical part of an apple scab disease management program. Removal or breakdown of fallen leaves and dropped fruit in the fall is the single most effective way to reduce primary inoculum levels in the orchard the following spring. So the fungus overwinters in dead leaves and decaying fruit on the orchard floor. So destruction of the leaf litter contributes to the reduction of primary inoculum. Leaf litter and dropped fruit can be broken down using mechanical, chemical, or biocontrol methods. Mechanical breakdown of leaf litter involves blowing the leaves from under the trees into the rows or alleys and then shredding with a flail mower. The application of 5% urea or of a biological control agent will encourage the growth of beneficial decaying microorganisms and thus increase the breakdown of the debris. This can be performed in the fall when most of the leaves have fallen, and then again in the early spring, about 3 to 4 weeks before bud break for maximum effectiveness. However, depending on the time of leaf fall and the beginning of snow cover, it may not be possible to do these treatments every year. So the breakdown of the leaf debris, either by mechanical, chemical, or biological means, allows for a reduction in the quantity of ascospores that will be produced in the spring. And research has shown that these sanitation procedures can reduce ascospores as much as 95%. However, regardless of the treatment, so regardless of whether or not you break down the leaf debris, the ascospore maturation pattern will not change. So the top line shows what the ascospore maturation pattern looks like, and it's a typical bell curve. And this pattern remains the same even with the fall treatment. So this yellow line shows the fall treatments. You can see that the pattern is the same. However, the quantity of spores released is lower. So if primary apple scab infections are controlled, secondary infections will be minimal, and fungicides are generally good enough to prevent Canidia germination from occurring on those primary lesions that do take effect. So fungicides are still applied using a calendar spray program. However, the interval time between applications is extended to 10 to 14 days from 7 to 10 days for the primary infection periods. Fungicides applied for secondary apple scab begin approximately 7 to 10 days after petal drop and continue until harvest. The last fungicide application will depend on the maturity date of the apple variety and the pre-harvest interval time of the fungicide. There are many effective fungicides that are registered for apple, and many of the fungicides that are used to control summer apple fruit diseases are also effective against apple scab. This concludes the lectures on apple scab. This depiction of the apple scab disease cycle is a favorite of mine because it breaks the cycle down by season and emphasizes that apple scab disease management is a season-long endeavor. The next lecture in the series of lectures on early season apple diseases will cover powdery mildew.